Hello, this is an informational video about our new genetic algorithm feature for the ChemML 1.0 Jupyter Notebook GUI. We'll start by opening a new genetic algorithm template. This template is set up as a simple machine learning workflow just to get the basic idea of how the genetic algorithm works. We use a sample data set from the ChemML library, which has smile codes and the homo energies in it. We represent the data using Morgan fingerprints, and then send that data to be split 90-10, training data to test data, and then that gets sent to the genetic algorithm block. Our genetic algorithm is a real value genetic algorithm for solving hyperparameter optimization problems. We predict the homoenergies of the test data set using the MLP regressor model with optimized hyperparameters. 5 text files containing Python code are required in order to run the genetic algorithm using the GUI. These text files are evaluate, parametric, single object, space, and test hyperparameters. The code for each of these can be found in our GitHub documentation. The evaluate file contains code which evaluates every individual tuple of hyperparameters and yields the results of the error metric for each generation. Once model type is selected in the wrapper parameters section of the GUI, the model is defined in this section for this section of code. For each generation, the hyperparameters of the model are set and the model is passed to the objective function, which evaluates the model. To better keep track of the hyperparameter optimization, a temporary file is used to gauge iteration process, which we will see later. The error metric file contains code which returns the user-defined error metric score for the data. The error metric returned in this function will define the criteria on which the best model is evaluated. The single object file contains code which fits the model to the data set using the hyperparameters defined in the evaluation function. The training data is split into n splits defined by the user, and an error metric for each fold is obtained. This function returns the mean error metric score of the k-fold specified. The space file contains code which defines the space variable. The space variable contains the list of hyperparameters we aim to optimize for the MLP regressor. And finally, the test hyperparameters file contains Python code which fits the model having the best hyperparameters obtained using the genetic algorithm to the training data set. The model is used to predict the values of the testing data set, and the function returns an error metric score of the predicted values and actual values. We're going to quickly look at the space file as an example. Here we can see the different parts that define the network, such as mutation and the different neurons. You can see here, if you want to make a change, you can just go and change in here or any of the files in a similar way. If your ChemML is installed properly, the file should autofill to the correct location in the GUI. And then if you want to make changes directly to the files, you'll have to go into your where you have ChemML installed, find the files, and then make the changes from there. Alternatively, you can have the files stored somewhere else if you want easier access to make the changes. And then if you do that, all you have to do is go into here in the GUI and put in the correct file path. For this example, I have opened my Jupyter Notebook in an adjacent file to my genetic algorithm files. So I just need to make a simple quick change to each of these, and then we should be all set. So go ahead and do that now. All right, and then once you have your GUI and files all set, you can run it. can see in here, it's going through each of the iterations. This takes quite a while, but we'll be able to see each one come up. Since it takes so long, I'm going to skip over to a pre-completed one. So this is what it'll look like when it's done, once it goes through all the iterations. And it'll spit out the best results at 5 interval periods. These are the best fitness values that it has found at any point during its evaluation at each marker of 5 iterations. So now if we move over to the total results it spits out, the best IND DF shows the accuracy scores for each generation of the algorithm, and the default is set to 25, but that can be changed by altering a year setup for the GUI. For the best individual, it again shows the best score it has found overall at 5 iteration intervals. And again, all the outputs for both of these can be adjusted in the GUI. So that's a brief overview of our genetic algorithm function. I hope that's helpful.